Kindly acknowledge. Am I audible?
Yes, ma'am.
Okay. So, last lecture we completed the unit 6, which was exception. And then I said in this lecture we'll start last unit 12. Reason is very simple because unit 'What is concurrency?' Because you are learning operating system, and that is why I am asking you. Now, now am I audible clearly? Is my voice? Then how you reply? My voice is reaching to you properly. You said no. Then how do you reply? It's like cracking or lagging. What is the problem? I changed the place. I changed the place. Lagging, how we can say, Mahek, I have not shared the screen. So lagging, you can't say, right? Right now, I'm not talking. Okay. So I'm getting the mixed response. Naisargi is saying clear now. Okay, so it was okay. Now it's clear. Is it clear now? Naisargi said it was.
Yes,
It is
ma'am.
clear. Okay, fine. Okay, okay, that's good. So we are starting unit number 12. Okay. So give me a second and I'll share the screen. Are you getting my screen? Concurrency is something which is Om Joshi saying multiple tasks performed at a time, right? Multiple tasks being performed at a time is the concurrency. And when concurrency is happening, we are talking in the terms of operating system or a software execution, right? And we say the software is a collection of programs, right? Software is the collection of programs. And as a software is collection of programs, what we want is we want our program to be connected. It's okay. You have to listen. That's not written in the slide. Dhruv, it's okay. Whenever it is needed, I can see because I am connected through my mobile also. So I'll, whenever it is needed, I'll show. Otherwise, you have to listen. This is lecture, okay? When the figure or some diagram is required, I'll tell you. Okay? You focus on my words. So I was discussing about a software being developed is a collection of programs. And when program is in execution, threads. So threads are the smallest individual unit of any program in the execution, fine? And is my screen visible now? Because you need to see now. Is it visible? Can someone acknowledge? Okay. So we were discussing about the content of this unit, which is going to be focused on what is thread states and its life cycle, how we can achieve the thread synchronization using Java language, creating and executing threads with the executor framework. Right? So this is the point of 3 point of discussion in unit number 12. Okay, so as I said, that whenever any programs are in the execution, it becomes process, and process table is being maintained by your operating system. And we know that to maintain the process, we require so many variables in the process table. Meanwhile, when we have a thread, we say threads are the smallest individual unit, right? Or you can say lighter weighted processes are the threads, right? So whenever we want to go with the concurrency, which is the name of our chapter, and you can allow multiple tasks by taking by happening or executing at a one time. So this is called multi-threaded idea about the programming, right? Multi-threaded programs extends the idea of multitasking, taking it in a lower level. Fine, that's the striking feature of your programming framework, object-oriented programming using Java. Now, whenever whenever I want to perform some task, because each and every program is doing so many tasks, such as we are creating the class object, we are creating the Java API object, we are creating the Java application, we are creating the Java application. So in order to execute one thread, more than one task are being achieved together. Fine. Have you learned process and thread life cycle in operating system? Am I audible?
Yes,
Okay, so just kindly say yes or no. In operating system, have you learned the thread life cycle or thread states? Anyways, so I'm talking about this. You see, what we have is we will have a thread queue, right? Which is which is dividing your entire program into the small task, because when your program starts its execution it becomes process, and when process is executing there will be so many tasks to be done, such as I said, the main method execution and calling some Java API class and doing some other thing, right? So what we can do is your entire program we can divide into the task. We will have a thread pool. We can create the thread. Your JVM will do that. We'll have thread 1, thread 2, and thread 3 for a single program, right? And we can execute it simultaneously, which is known as concurrency. Which is known as concurrency. Fine. So when we are doing so, there is a life cycle of stages or states which are attached to the thread can be at a time any one of these six different states. So we call it as a thread life cycle, right? So state number one is new, state number two runnable, state number three blocked, state number four waiting, step number five timed waiting, and state number six is terminated. Fine, these are the six different states of your thread life cycle. This is same as your process life cycle. If you have learned the unit number 3 process management, in the unit number 3 of operating system only we have concept of thread, and we discuss about the thread life cycle also in that. Fine. So this six different states of your thread life cycle can be executed like this. It can be executed one by one. Inside code of it. We have not started executing code, but still a thread has been created. It has been initialized by your operating system. So we call it as a new state. We call it as a new state. Is it clear, everybody? Code has not started, but thread has been created by your JVM, right? And JVM is talking to your operating system. Is it clear? Am I communicating? Right? Am I communicating, guys?
Yes, ma'am.
Yes or no? Okay. So from the new, your thread will go to the next state, which is known as runnable, which is known as runnable. Now, what is runnable state? What is runnable state? Once we invoke the start method, because your start method initialize your thread. So once the start method is invoked, the the thread will be in the runnable state, right? So start method may not necessary that it will keep on running, because when there are certain time slice which is exhausted, because we have already learned about the different process model. Yes or no? We have learned about a different process model, and we know that at times we will have first come, first serve, or round robin process. So when we have a thread, first runnable state, right? Right. So when we have a thread, first it will be the new state. It means code is not executed. From new state, it will go to the runnable state when start method is invoked, right? And when the start method is invoked, now thread start is ready to run. But it is not always keep on executing. Instead, it will be suspended for a time slice by your operating system, right? When and it will be given chance to the other thread, which we call the multi-threading, right? Other thread will work. One thread was going, it is like in progress, and now the other thread is working. Fine. So from the runnable state, your thread will time out block or waiting. It is temporary inactive. Blocked means blocked means right now we cannot process further, because there are chances that we may have deadlock, and because of that we are blocking the thread, right? So that is the block thread, right? So what block will do, it will acquire the lock, right? It will try to acquire a lock, and if it does not acquire the lock, then it will start fine. Similar way, the other state which we have is the waiting state. In the waiting state also, your thread is inactive, right? So it does not execute any code, and it is consuming the minimal resources. The minimal amount of resources are being consumed when thread is in the waiting state, because right now the portion of the thread which is executing, the portion of your program which is executing, it is waiting for a resource, and that's why we said it is in the waiting state. So it will wait for the notification, and when the notification arrives from the waiting state, it will be back to the runnable state. Fine. Again, in runnable state, it will start running. Fine. Again, from the runnable state, there are high chances that your thread can go to the waiting time. It can go to the waiting time state. The waiting time state is occurring when we have a time slice notification. As we said, every time it will not run. When the time slice comes, it has to stop its execution, right? So your block waiting and time waiting are the inactive state. They are the inactive state of your thread, right? So when other thread is inactive, completed, like runnable state and all the code has been executed, at that time your thread state will move from runnable to the terminate states, right? So either it will exit normally by uncode exception, or we can, our operating system can kill that state. In both the cases it will be in a terminate state. Fine. Either normally it has stopped the execution, or it has caught an exception. When exception occurs, at times like a thread has to terminate, or some reason, because of the some reason your OS or kernel is killing that thread, right? So these are the six states of your thread. Is it clear theoretically? New? Runnable? Block? Is it clear theoretically? What is it? These are the concept of OS, right? These are the concept of OS. We have to apply it in the Java, or in the programming framework. We need to fit it. Fine. Is it clear, guys? Now go to the runnable state. From runnable state, it will try to require the locks, and that's why it will be in the block state. When lock is required, again it will be on the runnable state. Right? And then from runnable state, if it has to wait for the resource, it will wait for the Hello, guys. Am I audible? Hello? Am I audible? Okay, up till what? Okay, fine. Right? Now, we're discussing certain methods which are attached to your. Write down visible if it is visible. Is my screen visible? Write down somebody visible in the chat. Is it visible? Okay, fine. So, there are two variations, that is void join with the no argument, and void join with the argument. right? Wait to die, right? Or wait to a specified time. Not state, right? It will return us the thread state. We are writing get state method. I'm sharing the screen, don't worry. We are having the get state method. So get state will return us the value of your thread dot state type, and it will give you the thread state, which could be either now my thread is stopped. Void stop. Suppose I want to suspend the current thread execution, right? Right. To suspend it, I have a method void suspend, right? Right. To stop, we have the method void stop. To suspend, we have method void suspend. So execution is going on, and we suspended it, and after suspension again we want to back again we want that thread back, right? So that's called resume. So we have the uh, method, last method of the slide, which is void resume. It will resume the execution of the thread from the suspended state. It will be again to the resume state, which is again the runnable state. Fine. Fine. So these are the few methods. The argument, get the state of thread, void stop, void suspend, and void resume. Don't worry, I'm sharing the screen. Are you clear with this 5 methods listing? Right? Yes or no? Are you getting it? Now we'll do one thing. We'll see a program so that we can have little bit idea what is going on. Otherwise, you will see Java multi-threading nature, right? So I'll show you. So give me a second. I'm showing you a program, thread creation. So all these thread related methods are there in the runnable interface. If I want to threads, I have to go with the runnable interface. Is my screen visible? Am I audible?
Yes, ma'am.
Okay, fine. My screen is visible, right?
Yes, ma'am.
Right? For that, you can use the runnable interface. So here we have returned class thread creation. So I have a file thread creation.java. I said implements runnable because I want to use the method such as public void run is the method of thread interface, runnable interface, which is allowing us to write some code which is there inside the runnable state of your thread. Public void run is the method of runnable interface. We say system.out.println thread is running. We have given a message thread is running. Now inside the main method I am creating the class object. I am, don't worry, I'm sharing the screen interface. Fine. So inside the main method, first I am creating the object of my class thread creation. I said thread creation m1 is equal to new thread creation because when I have a programming language, I have to create the object the task one. This is the task one to create an object of our class. And further, we can have the thread creation. So thread is an T1 equal to new thread and you are specifying M1. M1. So what is M1? M1 is our class object, the class in which we are writing the code, right? So thread creation class, its object we have created M1. And now we are creating the thread T1 for this object M1, right? Right? For the object M1. And now I'm saying M1, T1 dot start. T1 dot start. So this is like, it will call the runnable interface. It will just make your thread to go through the life cycle. And that's why when I say T1 dot start, when I say T1 dot start, it will start my thread execution, right? And when thread is running, when thread is started, it is a new state. From new state, it will go to the runnable state. So when it is going to the runnable state, it will call the method runnable interface. And from the runnable interface, the thread will be started, and from the started state it will go to the runnable state, and that's why it will call the run method. Is it clear? Is it clear, guys? Right? So if I execute this program, I say Java C thread creation dot Java, right? And I'm running by saying thread creation. So main method will be invoked and it will create the object M1 for the class thread creation. Fine. And for that M1 object, we are creating thread T1. So it will give me in the output thread is running. Fine. Is it clear, guys? Is it clear? Yes or no? Is the discussion clear? Have you seen the output? Have you seen the output? Have you seen the thread creation program? Okay, can you see it now? Fine. So I'm repeating. Class thread creation implements runnable. So runnable is the interface which contains the thread lifecycle related threads related method, right? We have taken a public void main, which is creating the object of our file name, that is our main class, right? Thread creation, M1 object is created, new thread connection creation. Now for the object M1, we are creating thread 1. So we say thread T1 equal to new thread M1, right? And we say So guys, I'm facing little network issues. Can you see the code? So this run method we have not called, right? We just started the thread. Okay, give me a last minute. I'll try for the last time. I'll show you the output and then we'll stop today because anyways our time is done. Can you check the code now? Can you see it now? It's okay. I'll show you this program next time. Now I guess it is visible. Yes or no? Java. So we've taken a class thread creation implements runnable. And so we just gave a message thread is running. Then we have created the main method. We created an object of thread creation m1 equal to new thread creation. We gave that m1 as an argument of thread object creation. So we said thread t1 equal to new thread m1. It means that start. So it will give us something like this. This will be output. So even if we don't have any direct call for the run method, we just started the thread. Then thread will be in from the runnable to run state. It will just from start to runnable state. It will give you the execution of the run method. Fine. It's okay if we are not being clear. I'll repeat it next time. But I guess this very simple concept which I have tried to explain. Can you see? Thread is running. Can you see it? Right? Thread is. And run we have not code, but when we started the thread from the new, it will go to the runnable state, and that's why it will execute the run method. Okay, so that's it for today, guys. Even we just started it, even dot start. Fine. Okay, so quickly I'll take the attendance and then you